Hello and welcome to the next video in the ALEKS explanation series. So today we're working on a problem understanding and predicting relative boiling point elevations and freezing point depressions of different solutions. So boiling point elevation and freezing point depression are colligative properties, meaning they depend not on what the solute is but on how many solute particles are dissolved. And it's really interesting in that no matter what you're dissolving in water or in any other solvent, your boiling point will be elevated, will go up, and your freezing point will be depressed, which means it will go down. So we're looking at these different solutions. The first one, you have 2.4 grams of hydrochloric acid dissolved in 500 milliliters of water. The next is 2.4 grams of potassium acetate dissolved in 500 milliliters of water. Then 2.4 grams of ethylene glycol dissolved in 500 milliliters of water, compared to 500 milliliters of pure water, and trying to determine which one will have the highest or lowest, the highest freezing, trying to rank their freezing point and boiling point relative to each other. So we can sort of discuss this to begin with, but remember that no matter what you dissolve, it will lower the freezing point. So the lowest freezing point is always going to be something other than pure water. So pure water is going to have the highest freezing point, and then they will go down from there. And the boiling point's the other way. The lowest boiling point will be pure water, and every solution with something dissolved in it will have a higher boiling point. So the instructions say select one in the second column next to the liquid with the lowest freezing point. And then you go up from there. So our highest freezing point would be pure water. And then in the third column, select one next to the liquid with the lowest boiling point, so that would be pure water. So we've got the first ones ranked in each series, and we'll decide from there. So notice we said with colligative properties, it depends on the number of solute particles dissolved, not what specifically they are. So that's what we need to go through here now, and just go with each one of these solutions and figure out how many solute particles are dissolved. And we'll do that in moles. So take the first one, which is 2.4 grams of hydrochloric acid. Start with 2.4 grams of HCl and convert that to moles. Using its molar mass of 36.46 grams per 1 mole, we would get that there are 0.06583 moles of HCl dissolved. Now we know that since hydrochloric acid is a strong acid, when it dissolves in water, it splits up into H pluses and Cl negatives. So it's a 1-to-1 molar ratio because there's 1 H plus on each HCl and 1 Cl negative on each HCl. So we would get 0.06583 moles of H plus dissolved and 0.06583 moles of Cl negative, and if we combine that, the total moles of solute are 0.1316 moles in that solution. Now we would do the same with the next one, 2.4 grams of potassium acetate, and we're going to do exactly the same process, so I'll just write it down really quick. 98.15 grams per 1 mole for potassium acetate gives us 0.02445 moles of potassium acetate. Then we have the exact same situation. This is an aqueous or a soluble ionic compound, so that means it splits up into its ions, which are potassium and acetate. So we have, it's 1 mole of each in this particular compound, so it works out the exact same way. Combine those two together and we end up with 0.04890 moles of a solute in the potassium acetate solution. The next one is ethylene glycol, a molecular compound, and its formula is given above as C2H6O2. Dissolved in water, do the exact same thing, molar mass 62.07 grams per 1 mole, and we get 0.0387 moles of ethylene glycol. Now, ethylene glycol is a molecular compound. It's not ionic and it's not a strong acid, so it does not split up into separate ions. So we leave it exactly as it is. So now, to decide which one would have the greatest effect on freezing point or boiling point, we just look at what one has the highest number of moles dissolved in the 500 milliliters of the water. So you can see right away that the highest number of moles is the hydrochloric acid. So that would have the strongest effect on freezing point, which would mean it would lower the freezing point the most. So that would make that the lowest freezing point, and it would have the highest effect on boiling point, which means it would raise the boiling point the most. So we'll rank that as the highest boiling point. Then we'd go and find the next most. The next most is the potassium acetate, so it would have the next lowest freezing point and the next highest boiling point. And then from there, we would fill in the ethylene glycol as the next lowest freezing point and the next highest boiling point. Sorry, the next highest freezing point and the next lowest boiling point. And that's it for the problem. Now, if we wanted to go ahead and actually calculate the change in the freezing point or the change in the boiling point, we could plug that into the freezing point depression equation, which is the change in the freezing temperature is equal to the freezing point depression constant times the molality. Or for the boiling point, it would be the change in boiling temperature is equal to the boiling point elevation constant times the molality. But this particular problem doesn't ask us to calculate this, so we won't go ahead and do that right now. And remember, molality is moles of solute divided by kilograms of solution, if you were to do that. Thank you very much. Happy studying.